Have you ever wondered how data is managed and manipulated in databases? Well, the secret lies in SQL, the structured query language. This powerful programming language is the backbone of most relational databases, providing a standardized way to interact with them. From querying data to updating records and managing database structures, SQL plays a crucial role. It's like the Swiss Army knife for data management, allowing users to perform a variety of tasks with ease and precision. SQL is supported by most relational database management systems, including MySQL, PostgreSQL, Oracle, SQL Server, and SQLite. This wide-ranging support underscores its importance and versatility, making it a vital tool in various industries. Whether you're a seasoned programmer or a curious newbie, understanding SQL can greatly enhance your ability to work with databases and efficiently manage data. So, are you ready to dive into the world of SQL? To start, let's understand what databases and tables are. Picture a library. A database is like the library itself, a structured collection of data. It's organized for efficient retrieval and manipulation, much like a library organizes books for easy access and reference. Now, within this library or database, we have tables. Tables are akin to the shelves in our library analogy. They are collections of related data, neatly organized into rows and columns. Think of each table as a specific genre or category of books. Within these categories, we find individual books, which in our case are the rows of data. Each row represents a single record. Just as each book in a library tells a unique story, each row in a table encapsulates a unique piece of data. A table can have thousands of rows, just as a library may have thousands of books. Now let's talk about columns. Columns are different attributes of the data. In terms of our library, these would be the different details about the books, such as the title, author, publication year, and so on. In a table, you might have columns representing attributes like name, age, address, and more. When we put it all together, a database is like a library full of various genres of books, each represented by a table. Each book or row within these tables has unique details or attributes, represented by the columns. This structure allows for efficient data management. It's like being able to walk into a library and know exactly where to find the book you're looking for, down to the shelf, the section, and the specific spot. In a database, this translates to being able to quickly and accurately access, manipulate, and manage data. With this structure, databases can handle vast amounts of data, making them indispensable in today's data-driven world. They're used in everything from small-scale applications to global systems, making database management an essential skill. Now that we've understood what databases and tables are, let's move on to how we interact with them. So, how do we interact with databases? We use something called queries. Think of queries as polite requests. We're essentially asking the database to provide us with specific information. And the language we use to make these requests? That would be SQL. Now, the most basic type of query, and arguably the most essential, is the select statement. The select statement is like the bread and butter of SQL. It's used to retrieve data from one or more tables in the database. Let's break down a typical select statement. Imagine you're seated at a grand feast, and you're asked to select your dishes. In SQL terms, the dishes are your columns, and the feast is your table. So our statement might look something like this. Select roast_beef, mashed_potatoes, from grand_feast. Here, roast_beef and mashed_potatoes are the specific columns we want to retrieve from the grand_feast table. But what if the feast is just too grand, and we want to limit our selection? That's where the where condition comes in. This condition allows us to filter our results. So if we only want dishes that are not spicy, we would write, select roast_beef, mashed_potatoes from grand_feast where spiciness equals not spicy. And voila! Our SQL query has just served us a delicious non-spicy meal of data. But remember, SQL is more than just select statements. It's a versatile language that allows us to interact with our database in various ways. We can add new data with the insert statement, modify existing data with the update statement, and even remove data with the delete statement. That's the beauty of SQL. It's like having a conversation with your database, asking it for what you need, telling it what to change, and sometimes what to let go. That was about retrieving data, but how about adding or modifying data? Let's find out. Adding and modifying data in databases is an integral part of managing them. This is where SQL commands like insert, update, and delete come into play. Let's start with the insert command. Its purpose is to add new records to a database table. So, suppose we have a table named Books, and we want to add a new book to this table. Here's how we can do it. Insert into Books. Title, author, year _ published, values, Moby Dick, Herman Melville, 1851. In this command, we're specifying the table, Books, the columns we're adding data to, title, author, year _ published, and the values for each column. Next up, we have the update command. This command allows us to modify existing records in a table. Let's say we made a mistake with the publication year of our Moby Dick entry, and we want to correct it. Here's how we can do it. Update books set year _ published = 1851, where title = Moby Dick. In this command, we're specifying the table, Books, the column we're updating, year _ published, the new value, 1851, and a condition to find the record we want to update, where title = Moby Dick. Now, what if we want to remove a record from our table? That's where the delete command comes in. This command allows us to remove records from a table based on certain conditions. For instance, if we no longer want Moby Dick in our books table, we can remove it like this. Delete from books where title = Moby Dick. In this command, we're specifying the table, Books, and a condition to find the record we want to delete, where title = Moby Dick. These commands, insert, update, and delete, are fundamental to manipulating data in databases. They allow us to add new records, modify existing ones, and remove records we don't need anymore. But remember, with great power comes great responsibility. Always double-check your commands before running them, especially when updating or deleting records. You don't want to accidentally modify or remove the wrong data. Also, keep in mind that these are just the basics. SQL is a rich language with many more commands and features that allow for more complex data manipulation, such as modifying multiple records at once or updating data based on the results of a query. As you continue to learn and practice SQL, you'll discover more and more ways to efficiently and effectively manage your data. So we've learned how to add, update, and delete data. But what about managing the structure of the database itself? Managing the structure of a database is as important as managing the data within it. When it comes to SQL, the create table statement is our primary tool for establishing new structures. It's essentially like laying the foundation for a building. The syntax of this statement goes as follows. Create table, followed by the table name, and then a list of columns with their respective data types enclosed in parentheses. For instance, if we're creating a table named Students with columns name and age, our SQL command would read, Create table students, name text age integer. Just as we can create tables, we also have the power to remove them. The drop table statement helps us do just that. It's the equivalent of demolishing a building, leaving a clean slate for new structures. The syntax is straightforward, drop table, followed by the table name. So if we want to remove our students table, we simply write, drop table students. It's crucial to remember that the drop table command is irreversible. Once a table is dropped, all the data within it is permanently lost. So always double check before hitting that execute button. In SQL, every statement we make shapes the database, much like a sculptor chiseling away at a block of marble. With the create table and drop table statements, we can mold our database structure to fit our needs perfectly. And that's how we manage the structure of a database using SQL. So let's quickly recap what we've learned today. We've explored the foundations of SQL, discovering how it empowers us to interact with databases. We've delved into the structure of databases and tables, and how queries can retrieve, insert, update, or delete data. We've navigated through the select, insert, update, delete, create table, and drop table statements, shedding light on their functionality. Remember, SQL is a versatile language with many more advanced features and functions, so keep exploring and happy coding!